صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. Okay, can you see my screen?
Yes, madam.
Okay, it is recorded, right? On your device? I hope so. Okay. Last time we stopped at superposition, and this one we have done this one using the Jamboard, right? And you guys have tried that. Okay, let's look at practice 4.3. 4.3 we have this superposition. Did we discuss this before or
Not yet.
not yet? We haven't even draw anything Okay.
Yes.
Kalau tak ada, okay, tak apa, keep. Ada orang baru masuk. Amirul baru masuk. I want to take this one out. Control C. And then I will give you the Jamboard. The Jamboard. Whiteboard. Start a new whiteboard. Okay. Whiteboard is a Jamboard.
Yes,
Did it share with you or not? Okay, good. Can you draw something?
It says denied. Yeah.
Okay, sebab dia automatically apa dia panggil, dia just share view the Jamboard, not editing. Okay, I will. Now, can you draw something? Or say cannot? I give you the new one. I think the same link.
Boleh, madam.
Okay, okay, good. I hope semua orang dah masuk. Mana Jamboard? Hilang dah. Yeah. Okay, I will paste the thing. Boleh tak paste? Tak boleh. Okay, Control C. Then go to here, Control V. Okay, good. All right, you can see this, right? Okay, still remember what is superposition? How to apply superposition? New one. So how many steps here? If you look at the question. Kita number one,
Three.
Three or two? How many steps? Bukan dia steps. How many? Sebab our aim is V0, right? So how many steps there? How do you want to look at this? The steps. You look at the independent source or dependent source, or both?
Independent.
Independent, right? So how many independent sources?
Two.
V2. So there is two steps. V0 1 plus V0 2. Okay, good. Can somebody draw? Number 2, drawing, right? Drawing the circuit when V0 is turned on. And number 3, I put here. Okay, so can someone volunteer draw when V0 1 turn on? And number 3, when V0 2 is turned on. V0, this is V0. This is the first one turn on. This is step number 2. This is step number 3. Alamak. Adam. Mana? Adam. Okay. All the Adams. Just show up. Okay, Adam. Assalamualaikum. Adam, can you go to... Kat sini dah tak ada orang. Okay. Tak apa, tak ada orang. Okay. I hope our Adam join this Google Meet. Okay, draw this one. Yes, very good. Oh, the third one. Adam Haikal pula. Adulah, Adam join. Assalamualaikum. Waiting for others to join. Okay, saya Adam pun tak masuk dalam ni. Good. Okay, don't forget the resistor. Alright, good. Tapi step number 2, not finished yet. You should draw the V01. Dia bukan V01 turn on, right? Dia patutnya this one 35 volt. And then this one 7 milliamps on. The current source and the voltage source. Okay, very good. Okay. And then you should draw this one. I5. This one should be I5 1. Okay, the current direction. And here, can someone draw this one? This part? This part. V note. V note what? V note 1. Yes, good. Okay. This is not 7 milliamps. This one should be 20 kilo ohms. And this part, 5I5 1. Okay, this one wrong. This one, what is the value? 5I5 1. This one, 35 volt. Okay, this part, step number 3, this is 5I5 2. And this one also 5I5 2. And then, yes, this one correct. This one, resistor 20 kilo ohms. Okay, this is good. 7 milliamps going down. And this one also correct. This one correct. Okay, good. Okay, bagus. Okay, macam ni. V02, V01. Okay, current direction jangan lupa nanti awak salah buat. Put the current direction. And this part, yes, correct. Bagus. This one also good. Okay, good. Now, saya rasa sebab saya dah discusskan benda ni. Saya macam ingat-ingat lupa dah ni. Okay, so what you apply here? Brothers and sisters, what do you want to apply? Which method? For step number 2. We go one by one. Step number 2. What do you think? You want mesh analysis or nodal? I think nodal, right? Because if you put nodal, then this one becomes V01 at here. All this node here. This is all V01. How do I know V01 here? Because of
reference. Bawah tu 0. Ground.
Yes. Tapi kita tak letak. Kita should letak this one first. Because if nodal analysis, you need to put the reference point. And then what is this one on the left side here?
35.
35. Very good. This is 35. You just write down whatever node that you found the value, you give it the value. So this is all 35 volt. Okay, then you put the current direction of each, right? Because this is node analysis. And you put this one and this one. Okay, good. Then the next step is, what should you do? You apply what? If using nodal analysis.
KCL.
KCL at node number V node 1, right? So because this is the only node that have no value, then you should put KCL at this node. And do we have any super node?
No idea.
No. A super node is when you have a voltage source in between two nodes. What types of two nodes there? Unknown nodes or
Unknown.
unknown? Right? So we have a known value here, and this is also a known value, which is 0. So there is no super node. Okay, good. And then apply KCL. So you have first 5I51, right? 5I51. And then number 2, is it equal or plus something? Which one entering the node V node 1? We have 5I51, and then this is entered. This one entered. This one leaving, right? Okay, so what is the value for entering nodes? Number 2. I51, right? Is it correct or wrong? V node 1 minus
Yes.
0 over 20k. Yes, very good. But what is I51 equal to? Anyone volunteer?
V not 1.
V1? Mana
And V
V1?
not 1.
Are you sure?
Yeah.
You can take out this one. This is the resistor 5k, and then the value is 35, and then the current direction is this way. This is I51, right? So what should you do? This is V node 1. What is I51?
35 pula. V not 1
35 minus V node 1, yes, correct. And then,
over 5K.
ya, betul. Ada yang tak faham kat sini? Anyone? Tolong mengaku. Kita tak apa mengaku dalam kelas. There's no problem. Asalkan you guys do understand during the class time. Why not we macam V node 1 minus 35 divide by 5 kilo? Why not this one minus this divide by 5k? Kenapa nak 35 minus V node 1 divide by this? Kenapa?
Direction.
The current direction here. And it follows passive sign convention. Passive sign convention says what? Current entering a passive element should have what? Positive or negative?
Positive.
Yeah, good. Okay, this is positive, this is minus. And then we should have higher polarity should be minus with lower in polarity. That's why we have 35 minus V node 1. But since this is a current, then you need to have voltage divided by resistor. That's why you divide by 5k. Okay. Now you can reduce this equation up here. This is 6I51, and we know that I51 is 35 minus V node 1 divided by 5k into V node 1 divided by 20k. Then you can do the math lah. So into 20k. Kalau macam ni kita dapat berapa? 4, right? 4 24 into 35 minus V node 1 equal to V node 1. I put V node 1 kat sini lah. Okay, there's one friend here. Siapa ni? Afiq. Aduh. You guys should use proper picture, your face. Do not blur your face. Then do not give your neck picture. Only your face. So that we know you guys. Macam pertama cheat teachers yang tak pernah jumpa and your friends pun tak pernah jumpa you, right? So give your proper picture. Okay. Okay. Sekarang ni 24 into 35. Berapa? Saya kehilangan nota lah. Jadi saya tak tahu jawapan saya ni macam mana. I hope you guys pun try so that we can compare our answer. This one 24 V note 1. And then this is V note 1. Tambah. So we have a V 1 840 divided by 25. Correct or wrong?
Yes.
Okay, good. And the answer is this one I got. Kalau kita salah, kita you point me. Okay, this is number 1. V note 1. Okay, number 2. What do you want to apply here? Apa yang macam rasa senang sikit kalau if you apply that? Do you realize something? Okay, sekejap. Saya this one is a note. See? What do you think?
Analysis.
Nada. Okay, good. But if you look at here, the blue color and the yellow color here, is it all elements here in parallel or not? Parallel ke tak?
Yes.
Yes, right. Bagus. Okay, kita buat macam ni. This is 5, 5, 2. And then kita letak macam tu. Then we have a resistor. 5 kilo ohms. Then we have the current direction going down, right? Then this is 7 milli. Then we have 200k, 200 but 20k. Nampak macam senang sikit ke?
Nampak senang sikit.
Right. So the upper part here is actually V note 2. And then down here is the negative side of V note 2. If you want to apply here, actually the 5k here and 20k they are in parallel, so you can actually combine. Untuk the current here, this is going up and this is going down. You can have plus minus, right? Dia boleh you can sum these two. Okay, tapi one direction going up positive and another one going down, so it's negative. So you can actually plus minus that one. Okay, boleh selesaikan this one or not? I give you some time. Do anyone volunteer here? Ataupun should I remove the left side? Patut saya remove ke tak? Padam this side.
Page baru.
Okay, page baru. Okay, page baru. Okay, if you use the screen, macam ni, or you can go straight to the page number 2. Boleh juga. Okay, so 5, 552. Okay, resistor combination is 5k and 20k. Okay, go to page number 2. This is going down. This is V naught 2, 7. So what is V naught 2? Anyone? Tapi sebelum tu mungkin the current. 5I52 minus 7 milli. But where is I52? Saya dah lupa pula dah. I52 is going up, right? Going up at here. I52. So, oh tak boleh juga combine. Sorry. We cannot combine this. Sebab this is I52. If you combine, what you can, if you combine, you're going to remove I52. So I will remove that one. Do you know what I mean? Kat sini. If we combine, we're going to remove the 5K there. The I52 here. If we combine resistor 5K and 20K, we're going to remove this this current I52. Faham ke? Do you get me? Faham tak? Sebab
No,
if it is not really, okay. Sebenarnya for each of these branches, dia macam ni. Okay, I put a yellow color. This branch going up, okay, and this branch going up, the current. And then the 20K here, maybe the current is, let's say we put a going down. And then the last one going down, okay. Each one of this branch actually have their own current. Okay, so you cannot simply combine these two resistors. Because when you combine these two, you're going to remove the current at here, current through 5K and current through 20. Okay, because when you remove this one, that's mean you remove this dependent current source here. Kalau dia tak ada kena mengena dengan this one and this one, dependent current source here is not, depends on the value coming from this 5K. Then tak apa, you can actually combine these two, 5K and 20K. So in our problem here, you cannot combine. Do you get me? You still tak
yes,
faham?
madam.
Okay, alright. But the current here and current here, yes, you can combine. No problem. Sebab dia current source. Cumanya how you want to draw ni macam susah sikit lah. Dia macam tak reti macam mana you want to combine it. Okay. Yelah, kalau this one going up, this is going down. So 5I52 minus 7 milli. Okay, this is the current source of these two. Tapi apa kita nak ni? Kita nak cari V naught 2, right? It's either you apply the nodal analysis at here, or you want to apply what we call that, apa awak nak apply kat sini? Maybe current divider pun boleh. So if current divider, you need the current. Current is this plus this, dua ni. And then into what? Into the current the resistor opposite, which is 20K, divide by 20K plus 5K. Okay, if you want to use the current divider, and you straight away get I52. Right. Tapi there's another way. Another method is applying nodal analysis. Then the whole node here is a V naught 2, right? Correct or wrong?
Yes, madam.
And then you can do the KCL. KCL where? KCL at V naught 2 node here. Clear. Sampai je aku. Okay, this one. Okay, so let's try. Katakanlah you want to use this nodal analysis. So KCL at node V naught 2. This is the node V naught 2. Okay, so the current entering should be equal to current leaving. So 5I52. Okay, number 2, which one is current entering? Plus which one? All,
I5.
I5 okay. And then equal, right? Current living. What is the current living? Oh, kita tak ada pula current ni. Susah juga. So this is V02
Over
minus
20K.
0 over 20k. Good. And then plus, right? Plus 7 milliamps. But do not put the unit ampere outside. Okay. Now, can we solve this? Not yet, right? Because we have I52. What is I52? Equal to? Volunteer? What is I52? You can take that thing out. This is 0. This is V02. And this is 5k. I52 is in this direction. Okay, what is I52?
Negative V02 over 5K.
Okay, bagus. How do you get that? 0 minus V02 divided by 5k, yes. Okay, now you can simplify this one. Negative V02 over 5k and equal to V02 20k plus 7 milli. Alright. And then this one, maybe you want to multiply by 20k. Okay tak? Multiply here. 20k. And you get this one 4. And then equal to okay, tak apa, V02, and this is milli and kilo you can just remove because cancel out these two. So plus 140. And then this is plus, so this is 25. 25 V02 equal to negative 140, or V02 is negative 140 divided by 25. Okay, macam ni. Okay, do you get same as mine or not? If current divider, using current divider, then this is I52. Tapi kita tak nak I52 kita nak the other one. Okay, you do the multiplication and you get V02, which is V02 is equal to current. Kenapa saya buat macam ni? Tapi ni macam susah sebab what do you want is resistor darab dengan voltage kan? Oh, okay. Okay, patutnya senang lagi. So the current tak boleh. Yang ni no. Yeah, we use another one, Ohm's law. Ohm's law, I think this one better. Cumanya the current direction lah, kita tak tahu is it going up or going down. The current is 5I52 minus 7 milli into, this is a current, into resistor, right? So resistor is 5k with 20k. So you will get the answer, tapi on this side kita kena, we are not sure is it going up or going down, positive or negative. And then you also needs to know what is I52. Yes, I52 can be I think negative. So Ohm's law, I think this part is quite unsure. The answer is unsure because you have here is a plus, here is negative. And then the combination of this and this, you are not sure which direction going up or down. So you cannot actually macam confirm the last answer is actually negative 5.6. But you can try this one on the left side here. So the final answer, because our aim is V0. So V01 plus V02 is equal to 33.6 plus minus 5.6. Then you get the answer. Okay, everyone?
Okay.
Okay. So the answer is Do you get this?
Yes.
Yes, madam.
Okay, very good. Alhamdulillah. Right. Ada soalan before we move to the next one? Ataupun terlampau laju? Question? Next week we're going to have the quiz. Not this week because I wrongly choose week your midterm break. Next week is not a midterm break. Next week will be your quiz. Week number 9 is your midterm break. Okay, guys?
Okay, madam. Madam, so that means we have 16 weeks lecture.
Dia macam 16 weeks lecture tapi it's actually not. Dia nampak macam 16, right? Sebabnya ada kuliah hari tu dia if you look at here, nampak tak saya share this one?
Nampak ya?
Okay, this 8 dia macam 16, right? Tapi our kuliah engineering ni dia tak follow ada kuliah. Dia start 4th on the 4th of October. And then dia just sampai 8 ke sini. And then this one exclude to means a break is a break. And then the remaining is here. So the balance yang awak dapat tu after 14 weeks, 16 minus 14 is actually your revision week. So we actually wants to give you ample time untuk do revision. So the classes will be exactly 14 weeks. Kenapa dia orang buat macam ni? Sebab this 8 weeks yang pertama ni ada kuliah yang start lambat. Sebab apa dia start lambat? Sebab they want to prepare for face to face meeting. I mean face to face in the class, right? So since our kuliah tak buat face to face, cuma certain subject je yang buat face to face macam lab. So we have ample time lah untuk adjust the date. Sebab kena quarantine dulu kan before coming to the class. Last semester, yes, I had 1 lab. Bukan, 2 labs yang kena face to face, macam letih jugalah. Quarantine saja dah takes like 14 days. Last time bukan 10 days. So we face to face tu dah tengah-tengah semester. Masa tu pula dekat dengan Ramadan ke masa time puasa kot. Jadi macam nak raya lagi. So memang kesianan diorang. Okay. And then kalau tengok revision period kat sini 29/11 kan. So memang lama lah korang punya revision saya nampak ni. Saya tak tahu pula revision period sampai 2 bulan 2. I thought until early of January. And by the way, I heard lah they want to have a face to face by January. Macam I'm not sure they want you guys to have a final exam to be face to face ke macam mana? Sebabnya the way they put here, the revision period is until February. And then they put the exam week this time, right? So by February tu macamnya korang kena face to face ke, saya tak tahulah. Kita tengok meeting seterusnya, nanti I will inform you. Kalau yes, you guys kena datang ke kuliah lah untuk exam secara bertulis. Ini seronok sikit lah daripada korang suka online. Suka online? Entahlah. Ada. Hopefully during the class time korang betul-betul faham. That's why kalau boleh just stop me. Kalau you guys have problem dalam kelas, please tell me that I don't like this 1 hour and 30 minutes to be just the class macam ni. Letih kan? Saya tahu. Tapi sebab kita baru je tukar teams, saya susah sikit nak adjust, nak buat kelas macam my previous class. Usually I will do macam korang kena bertulis, banyak tulis lah, tengok video and then korang akan discuss dalam group, lepas tu korang akan present. Ataupun saya akan discuss one by one your answer. Tapi next class kot insyaAllah. So please advise me, kalau awak malu, you can text me macam personally so that I will macam consider your idea how to go about your class in more interesting manner. InsyaAllah. Okay? Jangan tidur ya. Saya tahu korang dah tak tidur kat masa ni sebab pukul 10 . Okay. Source transformation. Alright, this is the new chapter, not new chapter, the next subsection of your chapter 4. Very important. So what are they? You need to reapply this resistor in series. What resistor in series? You can do the parallel rules or you need to plus all resistor in series. Which one?
Plus.
Plus, right? Resistor can be added in series. What about parallel rules for resistor? What can you do?
1/.
Yeah, it's a parallel rules. You can do the 1 over something. Let's say you have this resistor 1, this resistor 2. So you can have a resistor 1 with resistor 2. Ataupun yang resistor invert of this plus invert of second and invert your answer overall. You get the equivalent. Okay, y delta or delta y. Use this if only if you do not have series or parallel. Okay. If you cannot find these two, then only you use delta y or y delta. Okay. Jangan terus masuk je buat delta y. Nanti awak sendiri yang akan suffer. Lama sangat awak. Kalau you spend too long, that's mean your method is incorrect. Okay, so it is a process. What is source transformation? It is a process of replacing a voltage source in series with a resistor by a current source in parallel with a resistor. Benda ni. Or vice versa. Macam susah sikit kan, tak apa. Okay, the two circuits are equivalent if they have the same current voltage relationship. Okay, maksud dia macam ni. Because of a voltage source here in series, you can actually transform. That's why the name is transform. What you want to transform? A source. Okay. When a voltage source in series, you can transform it to current source in parallel. Okay. This is for independent source transformation. Or you can also transform the second one here to number 1 here. Okay, it means current source in parallel to the voltage source in series. Faham tak? Do you get me or not? This one you can transform to this, or this one you can transform to the number 2 here. Okay. Okay. For dependent source, same. You can also transform a voltage in series with resistor and to transform current in parallel, or this to the first one. Okay. The source transformation is not possible when R equal to 0. Means that kalau R equal to 0, so change the color. If R equal to 0, katakanlah this one 0. Then what is R equal to 0? What types of electric element that equal to R equal to 0?
True wire.
A true wire. So dia macam ni rupa dia. Okay, a true wire. So when it becomes a true wire, dia takes another rules. Dia dah tak jadi macam a load here kan. So this one also becomes a true wire. There is no load macam ni. So you cannot transform. Kalau dia becomes a true wire, you cannot transform. You need this resistor. You need this another resistor here. But make sure this is in voltage in series, current in parallel. Same, kalau R equal to infinity, katakanlah R here becomes infinity, then it becomes what? What electric element you have? Open circuit. Open circuit, right? Open circuit or short circuit, open circuit. Okay, it becomes like this. And this one also becomes like open circuit. Macam ni. So they no longer be like a source transformation. You cannot transform this. You need the resistor in parallel with current source or resistor in series with voltage source. Okay, so far so good or not? Tapi there's another thing that you need to consider. What is that? Okay, if you look at here, kejap, boleh ke kita clearkan here? Okay. Okay. Okay, katakanlah ni. When you transform, there's voltage value here. Katakanlah this is 10 volt. And then a resistor here mungkin 10 juga. So when you transform to current source in parallel, this resistor also equal to 10, same like this 10 ohms here. What about IS? IS you need to use apa panggil Ohm's law. So IS equal to V over R, which is 10 divided by 10. Then this one equal to 1 ampere lah, because 10 over 10. Clear or not? Clear?
Clear, madam.
Okay, good. Same as if you want to transform from right to left. So katakanlah the first IS here you have 100 milli, and resistor here you have a 1K. So the first when you transform, it becomes R here becomes 1K, and then the voltage here becomes what? I into R, right? So you have 100 milli into 1K. So you have 100 voltage. Okay. Student, usually what they make mistake in my previous final punya students yang paper, they forget to bring this resistor into the transform one, this part. Please do not forget this resistor. It is always there. Okay. Yang ni untuk the next slide ni, it is just how they apply this thing. Tapi if you look at here, they apply apa case KVL around the loops, and this one KCL to this branch. Okay, so sama je. They just want to apa tadi tulis ni? They just want to show you that this is linear. So that's why you cannot apply if R equal to 0. Okay, dia punya rules sebab R here. So you cannot apply if R equal to 0 atau R equal to infinity. Okay, try this one. We start from this side. The current is flowing this side. Okay, what is resistor value? If you look at here, is this a series or parallel? From B to A. Series, right? So you can add 8 plus 1 plus 4 equal to?
13.
Okay, good. 13 ohms. Lepas tu, look at the current direction. It is going to the left. And then you found 2 volt. 2 volt. And then because the current enters a positive first, then you should put a positive, right? Positive 2. And then the current go to the next voltage source, which is 12. You have a negative, right? Negative 12. And then this one, is it a plus or minus?
Plus.
Plus 5. And then the 8 volt? Minus. Okay. Okay. And then it is equal to a positive or a negative 13?
Negative 13.
Okay, negative 13, good. Okay, this is V total. So how you draw this one is by doing like this. Where you start it is coming, starting from B point, right? So you should also start from B point here. And then because this is a negative, okay, you just put a negative first, and then plus, and the value is 13, right? So you just write 13 volt. Okay. This is how you draw the circuit. Okay, so the equivalent circuit is this. Equivalent circuit. Clear? You can start from A to B, no problem. Tapi you need to observe the plus minus sign. Okay? Clear? Saya saja letak yang kat bawah ni sebab kadang tu how do you want to draw ni maybe a little bit confused when you have a negative sign. Ada question? Question?
No, madam.
Okay, very good. Alhamdulillah. Okay, what about this one? Current in parallel. What should you do? Current in parallel. Macam mana? If you consider going up is a plus, then going down is minus, then what is the total or equivalent current value? Going up, plus, okay. And then we have two amps here. Is it a minus or plus?
Minus.
Minus, and then 5.
Plus.
Okay, plus. By the way, current in parallel, you can add. You can add all. So that's why we add here. So berapa? Equal to 12, right? Is it positive or negative? I didn't put a plus because of in our writing, usually a plus tu kita boleh ignore je. But a negative you need to write down. Since this is a plus, you can draw equivalent. A plus is going up, right? At first we put the plus sign going up, so you just draw a plus sign going up. Okay, what about these resistors? Since they are in parallel, then what should you do? Use what rules? Parallel rules, right? Okay, so equal to? Use your calculator.
4.8.
4.8.
Okay, good. Sebenarnya jawapan dah ada kat situ. Okay. So this is how you draw. Tapi I think the parallel rules ni senang sikit lah berbanding the series. Okay. Alright, now use source transformation to find I naught. Okay, the step for this is you look at find any voltage source in series with resistor, and you can actually transform this into a current source in parallel. Okay, by the way, how you want to transform if you look at here, we have a polarity, right? Plus minus. This is a plus minus. If you want to transform to the current, you look at the positive sign, then that one is the arrow. Okay, so going up, right? Because of the plus is up, then the arrow is going up. Okay, so vice versa, you can transform current source in parallel with resistor to voltage source in series. Second, you need to find any unknown variables. If you found that, let's say in our example here, where is unknown variable? And what it is?
I know.
I naught, right? Is here. Okay. I naught. Okay. So if you found that, you please do not transform. Do not transform this. Okay. Do not transform this. So only transform at the place with unknown bukan. The place with no unknown nodes. So mean to say you can transform this one because current source in parallel. And this one also current source in parallel, you can transform. Lagi kat mana? And then you can reduce until you get smaller size, right? Okay, jom kita try this one. Go to your page number 3, Jamboard. Page number 3, Jamboard. Okay, use source transformation to transform this. Alright, siapa nak try first? On the left side. Can you transform the left side first? Nak tengok korang faham ke tak? Use source transformation. By the way, in your panggil apa tu, exam, if the question asks you to use source transformation to find inode, do not use macam superposition or other rules. You need to use exactly what method they ask. Okay, to find inode. Okay. So, saya buat dulu. Okay, saya buat dulu you first what should you do? Find any resistor in parallel and resistor in series. You can combine that, right? So since 6 and 3, they are in parallel. So you can combine that and it becomes a 6 in parallel with 3 and do the source transformation of voltage source and current going up, right? So you have a plus at upper side and then the voltage is equal to 5 into 6 in parallel with 3. What is this one equal to? This is 2 ohm, so 10, right? Agree? Agree? Okay, good. Okay, sekejap saya letak this one so that you can see which and which we transform. 7 and this is inode. Every time you transform, do not forget the unknown. Okay, now can somebody transform for me on the right side of this? Use different color. Maybe you use green ke? Volunteer? If you have a resistor, you can add them, right, in series. Simplify that one first and then you can, okay, this one and this one you can add. And then you do the transformation. Use different color. Nanti tak nampak. You can use undo button, no problem. Okay, 5. But you need to do the source transformation of this. So where is this one? That tiba-tiba hilang. Yes, this is correct. What should you do? This one becomes a current source in parallel. This is 3, this is 5. Yes. Okay, all right, good. Tapi direction, where is the direction? If you are unsure which and which, you can actually tukar the thing macam ni, right? And this is the current source going up. And when you want to transform, it becomes like this is a resistor and this is a voltage. Tapi how you put it, the current direction? Yes, this is correct. For those who are unsure which to put, positive first or negative first, you look at the arrow. So it is plus minus like this. Okay, and then don't forget the 5 ohms. This is 5. And what is the value for voltage? Transform means you need to find the voltage value too. Voltage equal to?
15.
15. How do you know? 3 into 5. Okay. 15 volt. All right. Now, what is the next step? Next step. Any idea how to transform here? Okay, kejap saya padam yang ni. Saya buat confused je. What should you do? Next. This part, yes, you cannot transform. Do not touch because there's an unknown there. Next step. Can you do this part? Simplify this part. Any volunteer? Can we do it like this or not? Yes or no?
Yes, madam.
Why yes?
Because it is in series.
But there is unknown here. You cannot touch, right? So what should you do? Up until here je. Up until here. So here to here. Let me give the up until here. So can someone transform for me on the left side here? Up until the red point here. Okay, good. 15, yes, correct. Okay, good. All right. Okay, write down this. Please help your friend. And don't forget this. I know. Every time you do the next steps, please do not forget the unknown because maybe you will transform this unknown. You cannot transform this part. Okay, bagus. Okay, next. How you want to find I note? The mission is to find I note. Can you further transform this one? Yes or no?
No, madam.
No? Betul ke? Then how to find this one? Boleh kan? This part you can transform. This part you can transform. Can you transform this one? Okay, saya padam belah sini so that you have space. Volunteer? Okay, maybe saya start dulu. Kejap. Okay, let me transform on the right side. Okay. Okay, on the right side. So we have a resistor 5 and this is a current source going up. And this is 15 divided by 5. Then this is 3 amps. Oh, sekejap you are equal. Assalamualaikum. Ya, semalam. Betul. Oh, kejap ya. Kita orang sebenarnya dah hantar email tu, tapi rasanya there's no respon lagi lah. Belum. Tak boleh proceed lagi kan? Okey. Tak apalah. Nanti saya follow up. Okay. Ya, sorry sebab diorang ni macam kadang tu respon cepat sangat tapi this time macam lambat pula. Uh, Al-Farah. Okay. Betul. Okay. Lagi berapa minit? Betul. Okay. Alright. Terima kasih. Salam. Aduhlah. Okay, 7.5. How you get this one? 15 divided by 2. Okay, good. And this is ampere. Alright, this is 2. Yes, correct. Okay, now, can you further simplify this? The resistor are in parallel, right? Okay, can somebody combine that resistor in parallel? Okay, please combine. And then what about current? Current also we can combine. Okay. Volunteer. Ada sesiapa yang tak faham kat sini? Okay, saya combine. Ada yang nak cakap tu? Okay.
Madam.
Yes.
Positif negatif tu tak effect kat anak panah arrow kat apa? Current source.
Current source. Effect. This one, which one you unclear? The 15 volt ataupun the 15? Dua-dua 15.
Yang belah kiri.
Belah kiri. Okay. Because this is transformation. This one transformation in series, right? So plus is up. So we have an arrow up here. Can you see?
I see. Nampak.
Okay. What about on the right side?
The same.
It is plus here, so it should be up here.
Okay. Faham. Thank you, madam.
Okay, welcome. Right. Bagus. So what is 7.5 plus 3? Here.
10.5.
Okay, good. What about resistor?
1.43.
1.43. Semua dapat sama ke? Let me check. 2 with 5. Inverse is... betul. Okay, good. And we have here 7 ohm. Then what is the next step? What is I naught? You have 10.5. Then which one? Up here. 1.43 or 7? Which one? We know that yang bawah ni 1.43 and 7. Which one? This is current divider. Hmm.
1.43.
Okay, good. And then what about the sign? Here, a positive, a plus or minus? This is going up. This is going down. Same direction, right? Here to here, same direction. So is it positive or negative? Confused. Okay, buka your notes. A plus or minus? Sekejap, saya kira 1.43 divide. Macam lain je. Betul ke? Jawapan dia. Yeah, betul. Yes, plus. Alright, good. So the answer is this. Betul ke? Korang dapat yang sama ke?
Sama medium.
Good. Sekejap kita ada answer. Oh, okay, 1.78, yes. If you look at go back to your slide or go back to the screen now, it is equal to 1.78. Alright, ada soalan ke? Any question on this matter? Which part that you feel that uncomfortable? Senang ke susah source transformation? Ramai orang suka source transformation.
Boleh aja.
Boleh lah ya. Okay. Nanti lepas ni korang asyik pakai source transformation je. Tapi do not do that. Please take some time. Let's say lah kalau soalan is general, you can use any form, any method to solve that. Take a few seconds to check on the circuit. Is it good if you use source transformation, or is it good if you apply superposition or any other method? Take some time before you directly answer your question. All right, let's go to, we have like 50 minutes, less than that. Okay, this. Okay, kita try. Since we have ample time, go to your page number 4. Jom buatlah laju sikit Okay, siapa nak try? Nampak ke saya buat sekecil ni? Ke nak besar lagi? Alright. Okay, volunteer, siapa nak try first? Okay, I put the 4 ohms here, you follow later. Okay, this is 4 ohms. Anyone? You can start draw. Kita kena laju sikit so that kita finish 11:30 sharp. Okay, someone can do the source transformation here, or maybe here, and someone can draw this one. Okay, tak apa, tak cantik pun tak apa. Asalkan awak try. Okay, good. Yes, correct. Okay, good. Okay, this one correct. The polarity. Usually what I will check you guys on the polarity you transform and then the value. The green one here, is it enough? What about the 1 ohms? Okay, this one, yes, correct. 5 ohms here on the left side. Okay, the value is also correct. And the polarity, positive, negative, yes, good, correct. Okay, tak finish lagi ni. On the middle part, this part. Is this all? And then on the right side. Next, what should we do? Okay, I'll give hint. This green color here. What about this 1 ohm? Yeah, you need to put 1 ohms there. Okay, good. Right. And then on the right side, what should you do? Okay. On the right side, maybe I will draw for you. Good, there's someone. Okay, there's someone. On the right side, please someone complete the circuit. Okay, yes. 40. Where's here? Okay, the current, yes. Okay, good. All right, I think that there is, because you want to transform, okay. Okay, someone transform there, and maybe there is no more voltage, current there, voltage there. Okay, Chini. And what is the value for this current? And can somebody do this part, on this part? Resistor, you can add it all, because they are in series. 5, 4, and 1, you can add them up. Voltage also you can add. Can someone add these two? Voltage and then draw? Or I just draw but you give me the value. Okay, somebody already draw there. Okay. All right. Okay, this is ohms. Okay, good. Let's check. What is the polarity? Okay, let's check whether you have a correct value for this voltage. We start from here. So this is a negative 20. And then we have a plus 10. Then you get a negative 10, right? Like this. So when you want to draw this, you should start where you start. And this should be a negative sign first. And then the value is 10. Yes, both are correct. And then the value for resistor, 5 plus 4 plus 1. Yes, correct. Okay. Then you get this on the right side. But what is the value for this current source? Current source here? 10 divided by 40. 0.25. Okay. Now you have that 40 here. And this is the current source going up. And this is 0.25, betul kan? And then there is resistor 2. And this one you should not miss the I node. Okay. Then how to simplify this? Can you further simplify this? Maybe on the right side here, so that you get the current all in parallel. Can someone? Okay, maybe I just draw the current and the resistor, but you need to fill up what is the value for these two and what is the current direction. Okay, can someone? Okay, like this. Okay, 10, good. What about the current source? Okay, going up, yes. And this is 1 amps. Don't forget the unit, all right? Okay, good. Right. Now, what should you do? You can simplify this part, right? And then the current source. Betul tak? Yes, yeah. So, one with 0.25. You have, this is a current source. And then this is a resistor, simplified version. And then the last part, you have a 2. Okay, can someone fill up that one? This is I note. Okay, going up, yes, correct. 10 with 40. Yes, correct. 1.25, yeah, good. Okay, so last, we use the current divider. And I note is equal to 1.25 into what? This is 2 plus 8. Okay, so what is at this part? Upper part here. Can someone write down for me? And is it positive or negative? Okay, yes, correct. Into 8 and divide by 10. And the answer is 1 ampere. Yeah, correct. The sign is positive. Okay, clear? Alhamdulillah, before 11:30, right? Any question?
No, madam.
Oh, Alhamdulillah. Saya rasa senang kan untuk this. Okay, kita tengok. Okay, next time in our next class, we're going to learn on the Thevenin. If there is no question, or maybe you gather all your question, later you ask me. Okay, so we finish our class with Tasbih Kafarah and Surah Al-As. Subhanakallahumma wa bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. والعصر إن الإنسان لفي خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر. Alhamdulillah Rabbil Alamin. Saya tak tahu mana nak dapat attendance. Sudah. 38 je ni. Tak apalah nanti awak check whether you come or not today. There is 2 absent. Or 3. Okay. Okay, Assalamualaikum.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Bye.
Thank you, madam.
Thank you, madam.
Sama.
Thank you, madam.
Coding.
Thank you, madam.
Yeah.